In this video, we're going to try to prove the following, that x squared minus x plus 1 is different from 0 for all x's in R. This is a very good way to deal with this kind of questions. Okay, so we will try to do it in many different ways and give some explanation for this one, either using algebra or geometry. Okay, here we can treat this one as a function. Okay, so we're gonna call it f of x is x squared minus x plus 1. So here our function is defined for all the real numbers. Okay, so if this one is 0, okay, that means there is some alpha. So we can find alpha real such that f of alpha is 0. This means that when we graph our function, okay, this alpha is going to be here. So alpha is going to be 0. That means it's going to be a solution of this equation. Okay, we will show that there is no such alpha. Okay, so it means that if we find it, it's going to hit the x-axis. Okay, and this will make our function 0. But to prove that there is no such thing, we can do it in many different ways. So either when our function is different from 0, it's either on this half or on this one here. Okay, so this is not the actual representation or the graphing of the function. This is just the explanation of what we mean when we say that f is not 0. Okay, so we can do this one here. We can see that if we treat this one as a second degree polynomial, so delta in this case is it's minus 1 squared minus 4 times 1 times 1, which is minus 3, and it's less than 0. That means there is no solution. That means our function doesn't hit the x-axis. Okay, so it's either here or on top. This means that we don't have a solution. That means there is no such alpha. Okay, and this means that this is always different from 0. Okay, we can also do it this way by completing the square. Okay, here we have x squared minus x plus 1. It's x minus 1/2 squared plus 3 over 4. Okay, by completing the square, we have this result here. Now we're going to use algebra to prove that this one is bigger than 0. Okay, so we know that x minus 1/2 squared, it's a square, it's greater or equal than 0, because when x is 1/2, we're going to have 0. Okay, that's why we have this equal sign. Okay, so here if we add 3 over 4 to both sides, we get x minus 1/2 squared plus 3 over 4 is greater or equal than 3 over 4, which is strictly bigger than 0. So here, this is what? This is x squared minus x plus 1 bigger than 0. So that means f of x is bigger than 0. That means when we graph our function, it's going to be here on this, on top of the x-axis, and therefore it will never hit the x-axis, and we can find an alpha such that this one is 0. Okay, but from here we see that our function has a minimum when x is 1/2, and the minimum is 3 over 4. So that means our function is like this. Okay, so this is our function here. So it's here. Okay, so the range for this function is 3 over 4 plus infinity. Okay, that means our function, our y, is always bigger than 0. That means the function doesn't hit the x-axis. Okay, so that's how we do this one. There is no x such that this one will make x squared minus x plus 1 0. There is no such thing, and therefore it's strictly bigger than 0. Okay, and this is the by completing the square, we see that we get the result that we need. So this one is always bigger than 0, and therefore it's always different from 0. Why? Because it's bigger than 0. Okay, so here we see that we can never get a solution, and therefore this x squared minus x plus 1 is always different from 0. Okay, so this is one way of doing this kind of questions. Okay, so we either prove that directly as we did here, or we can try to find the alpha that will make this one 0, but there is none. Okay, so in this case we see that x squared minus x plus 1 is different from 0, and exactly it's strictly bigger than 0 for all x's in R.